All right, friends, today we talked about writing and graphing inequalities, understanding minimum and maximum heights. In the real world, right, you've been to an amusement park and you know that there are height restrictions on rides that need you to be a certain height so that you don't go flying out of the attraction, or there's minimum heights or maximum heights for rides that it would be uncomfortable to ride, if you were older. So we're trying to understand this and put it into mathematical terms and help us understand how to graph it on a number line. And so this was the beginning of that. And so the first thing it asked us to do in this is it asked us to estimate heights of people. And so for the most part, we saw this picture and we said that, name a number in feet that is clearly too high for this man's height. I'm gonna say, 8 feet, because that is too tall for him. And then name a number in feet that's clearly too low for him. Well, I think maybe 4 feet is too low for him. So based off this estimation, my actual thinking of his height is somewhere in between these two numbers. So my estimate is probably gonna be maybe 6 feet, right? Could be his height. So that's kind of how I'm reasoning through that. And 6 falls in between, 4 and 8. And so that's kind of my reasoning behind that. Here's a picture of the same man standing next to a child. If the man's actual height is 5 feet 10 inches, which is pretty close to my estimate, what can you say about the height of the child in this picture? So the height of this child is in the picture is probably maybe less than 6 feet, so maybe 4 feet 12 inches, because he has to be less than 6 feet, also less than this 5 feet 10 inches. So I apologize for that. This is about reading. So 5 feet 10 inches, so that is less than that, and so the child's height should be less than the height of the man. And so this gives us an understanding of, estimating the sort of reasonableness of things, which will help us take the next step into the next activity. So in class, we talked about stories of 9 to help us understand how to graph and describe inequalities. And so, it asks us to compare, okay, so this one right here, so we're going to go through each one of these and do what it asks us to do. So it says a fishing boat can hold fewer than 9 people. How many people X can it hold? Description or list. Since we're talking about people, there's not parts of people, right? So we can't have half of a person. We can't consider, a baby not counting as a one person. Now, we're not talking about weight, we're talking about sitting people comfortably into a boat so that you don't have people flying off the boat when you hit a wave. So, description or list, my description is going to be any whole number less than 9. So, and remember, a whole number is any number that's not a decimal or a fraction, right? Because we can't have parts of people. And so to graph this, what I'm going to do is I'm going to place a marker or a dot above every number that is less than 9. And I'm not going to draw an arrow because remember, an arrow would indicate that I'm saying that 7 and 5/10 is a person that's possible, and that's not true. So any whole number less than 9, and I would place just dots. I'm not going to draw an arrow here. The inequality, so I'm going to say x is less than 9, and that's what I'm going to do for this example. For the next example, it says Covey needs more than 9 ounces of butter to make cookies for his party. How many ounces of butter would be enough? So butter is something I can cut into parts like halves, wholes, hundredths. It just depends, hundredths. It just depends on what I need, right? So my description or list is any number greater than 9. And in this situation, because 9 is not a value that's included, how I'm going to graph this is going to look a little different. So I'm going to make an open circle. And so we talk about this concept. Open circle means that 9 is not included in in making the inequality work, but any value that's greater than that would be any of these numbers. I'm going to draw an arrow just like that, to show that all these solutions to the right of 9 are possible solutions for this example. My inequality is going to say x is greater than 9. For the next one, it says Colin will perform his magic tricks only if there are at least 9 people in the audience. For how many people X will he perform his magic tricks? Well, he will perform for at least 9 people, so he will perform for 9. So this, again, since we're talking about people, can only be whole numbers. So we're going to say any whole number greater than or equal to 9, because he will perform for at least 9 people. And what we're going to do here is, again, since we're talking about people, I'm only going to place dots on the actual values that's possible. And so I'm not going to draw an arrow, because an arrow would indicate that half of a person is possible, and you can't really perform for half of a person. It's either a full person or it's not. You know, there's either a person or there's no person, is what I'm trying to say. My inequality for this is x is greater than or equal to 9. For this one, it says a food scale can measure up to 9 kilograms of weight. What weights can the scale measure? So this is up to 9, so it includes 9. So description or less, any number less than or equal to 9. To document this, it can be 9, so I'm going to do a closed circle here, which is different from what we did in B, because it can be 9. And I'm also going to do a closed circle around 0. We're not going to get into the theoretical, can you weigh something less than positive numbers, and we're going to draw an arrow indicating any numbers in between these are possible values. So my inequality is going to say x is less than or equal to 9, x is greater than or equal to 0. And that's what this activity was, is to get them acquainted with how we graph inequalities on number lines. And then in our last activity, we went back to this estimation activity that we did at the beginning, and now we're going to be comparing the heights of a basketball hoop and a person. So complete the first blank in each statement with the estimate, and the second blank taller or shorter. We use greater than, less than here. So I estimate the minimum height of the basketball hoop to be, the shortest I think it could be is maybe 9 feet. This means that the hoop cannot be shorter, and by that I mean cannot be less, right, than that height. I estimate the maximum height of the basketball hoop to be 12 feet. This means the hoop cannot be taller, which means it cannot be greater, right? I want to use that mathematical language than this. I'm going to write my 2 inequalities, one to show your estimate for the minimum height of the basketball hoop, and the other for the maximum height. We're going to use the inequality symbol and write the variable h. So I'm going to use h. For my first one, I said it has to be greater than, so h has to be greater than 9. But also, h has to be less than 12, because my maximum is 12 and my minimum is 9. So these are the 2 inequalities I'm going to write. For this one, I'm going to plot. So I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And basically, right, if I plot again, or write my intervals, what I'm going to do is that I'm going to put, it has to be greater than that, so I want to open circle, because I did not say that it has to be equal to that, but it can only go to this direction, so I'm going to go only to 12, because that's what I've deemed as my maximum. And from here, I did not say it could be 12, but it needs to touch 9, right? Just like that. And so remember, the open circle, or if you want to say the unfilled shaded, or the unfilled circle, is considered a value that does not, right, is not included in the possible solutions, right? And on the back, it says, suppose a class may estimate the value of h to be 19. feet. Does this estimate agree with your inequality for maximum height? 19 feet is not a possible solution. Because my maximum height for the hoop was 12 feet. And this one says ask a partner, so we're not going to do that. So that was our lesson for today.